factor and replication strategy. In replication strategy, there are two things, which is simple replication strategy and network topology strategy. So each node in Cassandra serves as a replica for a different range of data. Cassandra stores multiple copies of data and spreads them across various replicas so that if one node is down, other replicas can respond to queries for that range of data. This process of replicating the data onto a different nodes depend on two factors, replication factor and replication strategy. So replication factor is decides how many replicas the system will have. Replication strategy means decides which nodes will be responsible for the replicas. Okay, so let's look in deep about the replication factor. So the replication factor is the number of nodes that will receive the copy of a same data. This means if a cluster has a replication factor of 3, each row will be stored in 3 different nodes. Each key space in Cassandra can have different replication factor. Yeah. So the main thing is the replication factor can be given at the key space level. So when we define a key space, we will tell them what would be the replication factor on that. So if a cluster has a replication factor of 3, each row will be stored in 3 different nodes. Okay. So replication strategy, the node that owns the range in which the hash of the partition key falls will be the first replica. All the additional replicas are placed on the consecutive nodes. Cassandra places the subsequent replicas on the next node in a clockwise manner. There are two replication strategies in Cassandra. One is the simple replication strategy. This strategy is used only for a single data center cluster. Under this strategy, Cassandra places the first replica on a node determined by the partitioner and the subsequent replicas on the next node in a clockwise manner. Okay. So here, yeah, go ahead, Srini.
Is it in the same region or how is that? Same data center, right? This is?
Yes,
Okay.
same data center cluster.
Okay.
I think inside same data center, we can have a multi-clusters too, like one cluster connected with a couple of nodes and another cluster connected with a couple of nodes, but all of them are inside one data center.
So Srini, you can actually, you can specify whether you want a local or network topology. So in network topology, it will also replicate across the other zones, AZs.
Yeah.
So it depends what you specify at the time when you form the schema. That time there is an option when you create the tables. Then there is an option how you want it to be configured.
Sure.
Yeah. So that's about simple replication. Here I have one question about, they were talking about the partitioner. The partitioner is the one who decides the first node, right? Sorry, the first replica.
So the partitioner.
Mm-hmm.
So partitioner, and we have called partitioner is the primary node, right? For the data that is hosted in that node, right?
But here they were saying my understanding is the first replica is what the coordinator, right? Or because the coordinator keeps the node inside.
First replica is the partition key false is what, like hashing of the partitioning key, right?
Mm-hmm.
Yeah. Can you scroll up quickly?
Right. This is the partitioner, right? So the partitioner for me looks like the partitioner is not connected with any of the nodes. Is that true?
No, partitioner is the hash key for the partitioning key, right? Hashing is hashing of the partitioning key.
Okay. So basically, then can I consider that this partitioner is not built inside any of the node? It is something like a different one, which decides finding it out what is the hash function or hash key is going to be. That hash key decides what is the first replica, right?
Yes.
Yeah. So
to clarify,
yeah, good. No, I was just saying partitioner is just on a software on the client side, which will just based on the hash, it will come to know which node, it needs to be the data is expected. That's it.
Okay.
Also, to clarify, partitioner is different than the coordinator node. Coordinator node is the particular
Yes.
node where the request is getting served
But
from, or where the request reaches for the first time. But that has nothing to do with the partition.
but Aditya, partitioner node doesn't know, right? The actual node the data resides, right? Then there is no point of having the consistent ring, right?
No, so my understanding is partitioner is on the client side, okay, and which will decide. It's a simple hash function which will decide based on the hash key on which node your data needs to go, will be residing, right? But request can go to the any node, and that is a wherever it hits the first node is the that I think we are talking about two paths, read and write paths. And wherever the request hit, the first node is the coordinator node, and that will figure out where the data is. But if you're putting the data, if you're writing the data, then partitioner is on the client side, which will tell which nodes to write the data.
So what do you mean by client side here?
Yeah, that
On the user side?
which is the
Um,
database side or at the user side?
um, that's a good question. I think still
It
it
should
is still
never
in
be a
state
user
that
side, right? Because running a Malmar algorithm on the user machines or user instances, it's going to be costly, right?
Yeah, but I am thinking that in the properties file, right, we can define whether it is going to be murmur3 or any other hashing. So definitely then the Cassandra owns that, right, in the config file. I think so. Definitely, I have a feel that it is inside database, but it may be a different layer. The data layer could be different, and then the partitioner layer could be different. I remember I've seen that in one prop. I don't want to go to that, but I remember I've seen in the config file we define what is that murmur stuff.
Yeah. So we'll proceed then. Sagar, can you take this question? Okay. So
Sure, sure.
we'll post in the group. Somebody will answer and we'll connect.
I think since it's a leaderless, it could be the coordinator key, I feel.
Okay. Okay. Yeah. So we can move forward, right? I think we read till simple replication strategy. So I think, yeah, that we know that when we define, I'm sure that the replication factor, we put it under the key space level. I'm not sure we'll read that replication strategy. I think replication strategy also will define it at the key space level. So the node that owns the range in which the hash of the partition key falls will be the first replica. All the additional replicas are placed on the consecutive nodes. Cassandra places the subsequent replicas on the next node in the clockwise manner. So simple replication strategy, we read that this strategy is used for only single data center cluster. Under this strategy, Cassandra places the first replica on a node determined by the partitioner and the subsequent replicas on the next node in a clockwise manner. So this is the simple replication strategy definition. So yeah, go ahead.
One question somebody has it like, how do we configure replication factor? Right. So I think this is part of when you're creating
Yeah.
when we are creating a table, right?
Yeah,
Or
entry key when we are setting the entry key, right? The above they said, right, like how we are setting the replication factor. If you go little above,
Uh, yes.
I think the starting you read, right, like how the replication factor is set.
Yeah, which is at the key space level, right? When we create a key space, we say what is the replication strategy.
okay.
See, each key space in Cassandra can have a different. So that the bottom level it can go is only at key space level. Underneath the key space, we can create multiple tables, but I don't think it can go at the table level. So
Okay.
minimum it can go is at the key space level.
Okay. Yeah. Go ahead. Thanks. No.
Yeah. So till this one, I think this is just a simple strategy replication. So we have a client, and then the client picks up one coordinator. Okay, so I think, see, then I think then the coordinator node can be a partitioner key also, because here I see that the coordinator node is different compared to the replica. So there are three replicas and plus coordinator. So my understanding is the coordinator node is not considered for replication, right? here, at least in this sample, the
Yes,
coordinator node.
coordinator node forwards that request to the corresponding coordinator node receives the request. I think the client will send it nearest node, nearest,
Yeah,
that request to the nearest node, and then coordinator node will, based on yesterday, like kind of zookeeper or whatever, right? Snitch or whatever algorithm or
no, no,
software, right? That identifies where exactly the data stores in which node,
yeah.
right?
This
Then
coordinator
forward.
node also, this coordinator node also Cassandra node, right? This so this
Yes,
this
yes,
node like a coordinator node, but I think my thought process here is like, this node can act like a partitioner. It will find out what is the hash key, then it is figuring it out the first replica, then it gives
correct,
the request, and then the other consecutive clockwise will be added as other replicas, right?
correct, correct.
Yeah,
Yeah, even that's what my. So every node is along with the data partition or data node, right? It has more functionality of identifying uh, where it stores the data or which node has the data. Right?
yeah,
So I believe the gossip protocol always keep working, right? So as we are talking about the coordinator node, every single node simultaneously also acting as a coordinator node, right? As well as
yes,
the server node or replica node.
yeah,
So and when we say the gossip protocol, it will keep broadcasting it. So every single node will be continuing with multiple functions at the same time, I believe.
yeah.
But here gossiping about the health or their map, right?
No, no. I guess it's more about the data, the key space. I think key space is something that they gossip about.
Yeah, yeah, the map,
Yeah,
right?
yeah.
The but yesterday you remember when Mona was discussing it, we have a separate either instance or like kind of a zookeeper environment, maybe like that. The sort of Aditya was a snitch or something we are running. I think is it maybe that is on every node. I'm not sure that is. So.
No, no, that's not on the every node. No, no, that's just one. It's like a central piece. It's not on the every node. So when the request comes in, it goes to the coordinator node, right? So coordinator node will talk to the snitcher program, and that will tell which is the nearest node. So the basically the job of the snitcher program is to find the nearest node which has the data, first to nearest node.
So
Yeah.
then, Sagar, then further, gossiping is, I think, health between these servers. Then, right? It is not
Yeah.
gossiping the data, right? So,
But any new key space being added, let's say I store certain record on and I'm a coordinator node, let's say, and there are these three servers that we are talking about, which accepts the record. And so how would we propagate that this server is the replica of the other server? That's also another thing, and this record is being accepted. Basically, whatever the particular token hash value is, that is being stored in this particular replica. So the same node can have multiple replicas. So how would we propagate that as well? Is my question clear, Shani?
Can you come back again?
Yeah, so let's say if any new row is getting accepted, we also need to send that row to be returned to its replicas, or whatever whichever server handling that particular id of in our consistent action ring. So let's say there are three servers who are handling that particular key id, then it has to be propagated to that any write coming in. At the same time, let's say a new replica is getting added, then it has to get propagated to that new replica as well, right? That these are the keys, these are the rows that are being written currently.
Yeah, yeah. So my understanding is Cassandra should do a multi-threading, right? So I think it will. My understanding is couple of threads could handle current work, or I mean, if there is a write request directly comes to that particular node for a replica, right? It can do that, but that same node can be for one more node's backup replica too. So I think at any point of time, there's a chance that it could do multi-set of work. Is that the question, or?
Yeah,
so the question, if I understand right, even the other part, how do we identify the new row is added into that node?
yeah.
Okay, the coordinator node. Let's take an example, right?
Mhm.
So how the other nodes aware of that? I think that's also a part of question, right?
Correct.
Sagar?
Correct. I so my question was like how the other nodes, is this through the gossip protocol broadcast part as well? As we were talking about the health check, but apart from health check, we also need the new information being written to be broadcasted so that the corresponding node would accept that request and be able to fetch and update that part, or their copy of the records.
Yeah, my understanding is right. If so, minimalistically, we need at least three nodes to start with, right? So I think at that time, let's say we are doing a basic implementation, right? At least we need to have three nodes to start with. So all three nodes, I think, should have the seeds, right? There is one configuration called seed provider. So that's where we define the seed nodes, and then from there it can pick it up, and then we can dynamically add more. So my understanding is Cassandra will take that seed node first, and it will understand who are all the other providers, right? Like it can be running in a different port. So then it will take and start to do the gossip between those nodes. But there is a specific class name I've seen, like, simple seed provider. I can put that. So there is an interface implementation done in that. So that should take care of taking the seed and sending the data request, let's say. So each node is acting like a coordinator, right? So that it will do the hashing and then figure it out for that what node it allocated. So then that node and the port, it will do the call, and then it will take that node and then send the request.
So, but that node details will be there in every node.
Yes, there is a. My understanding is there is a specific config called seed provider. Let me ping you that. So in that, we have to do the configuration, because unless otherwise we don't start with any seed, we cannot go from there, right?
Okay.
So this is the, the Cassandra configuration. There is a specific section called seed provider, and then there's a class implementation, simple seed provider, and we need to provide all the nodes that we are going to register in that cluster.
Okay. So
Yeah. By
it's
the
like
way,
every
just a
node
time check.
has a.
Yeah, just a time check. I think we
Okay,
have
let's
been.
proceed.
Yeah.
Take up the question. Yeah,
Okay.
we'll leave.
So let me move
They were,
forward.
what do you mean by seed? Sorry, I didn't get. What is seed?
I read that, for example, when we start one Cassandra, right? For example, one node we start, so it will go to the properties file and then start to figure it out all the connected nodes, right? Because you can run Cassandra in one node. So in that case, you are not using, it's just one node. You don't need any replications or anything, right? But let's say how you will tell Cassandra that, um, hey, I'm running multi nodes, and these are all my neighbors. How that one node, let's say wanted to just run one node, right? You have just only one node, you don't need to do anything. But let's say you wanted to run 2 3 nodes, how each other nodes will communicate, right? So in the node, you need to tell these are all my seeds. So then when the all Cassandras comes up, all members will have their respective nodes. Maybe it could be a DNS name, colon port, or whatever the region. It could be in a single data center, or it could be multi-region. So they need to understand what is their respective VMs or nodes, right? So once it understands that, then okay, these are all, then it will run some logical and figure it out. Okay, so totally there are 5 6 nodes in mine. Then it can allocate the hashing, what how the hash ring should go, and then it can split all those things based on how we are configuring it.
Yeah. I I don't know because whenever we create the tables, so basically you can call it key space.
Mhm.
It is not on the one node, okay? It's not on the one server. It's across multiple servers. It's across the set of servers, and yeah, I don't know
Mhm.
how to explain that logically and physically. In the sense, like if uh, if one server will have only, I don't know. I'm not sure about that.
See, if you read that, like, Cassandra nodes use this list of hosts to find each other and learn and number the topology of the ring. You must change this if you are running. something like that they mentioned. But we can move forward, but we can make a note and then we can come
I
back
have
to that.
noted down the questions and everything, Deva. So we can
Yeah.
come back to it again if you need.
Okay. Yeah. So I'll jump to the network topology strategy. If anybody wants to take it, I can wrap this one and I can stop here. Then somebody can take it, but I'll quickly wrap this network topology strategy. So this strategy is used for multiple data centers. So the same thought process, we looked at single data center, right? Under this strategy, we can specify different replication factors for different data centers. This enables us to specify how many replicas will be placed in each data center. Additional replicas are always placed on the next nodes in a clockwise manner. Okay. So I think my understanding is let's quickly walk through this one. So this is a replication factor. I thought we would set the replication factor at the key space level. So I think let's say this is a node A or data center one. Oh no, data center one. Here the replication factor is 3, and in a different data center we can put the replication factor as 2. Um,
Yeah, I believe it's cluster to cluster basis, right? So one data center can have multiple clusters as well. So
yeah.
the replication factor they said, I think somewhere here they have mentioned that they said the replication factor for the cluster itself.
Yeah, but still it's applicable to key space, right? For example, I have a key space called users, right? That key space replication factor will be 3 in one data center, and in other data center it could be 2. But if I have one more key space called um, uh, employees, right? So in that employees, the replication factor could be 3 and 3 in both the data centers. So my question is around the replication factor can be varying based on the key space, right?
So I would I understand is you're confusing between tables and the key spaces. So table is what equivalent to employees and one more table that you said. So key space is holding many tables. So
Yeah.
one table, any one table you take employee can be on one node. If replication factor is there, then it can be on multiple nodes of the same data center. And if you have another data center on network and you have mentioned replication factor, then it can be on that other data center as well. So so key space level replication factor um, applies. So if you have multiple tables will replicate accordingly. So one table, say you have department table again,
Yeah.
and so whatever is at the key space level,
Yeah.
three replication on data center 1 and 2 replication in data center 2. That's how it will go.
Yeah, I'm also in the same page. Maybe the example that I gave could be wrong, but I think I was also in the same understanding that it is like at the schema level, right? If we think from the
Yeah,
RDP,
yes, yeah.
from the key space perspective, I'm
Hmm.
also on the same page. Yeah.
Yeah.
So yeah, we can take a quick look. I think this is clear. So I think here there's a coordinator node call comes in to the data center one. So what it does is like it just goes and figures out the first replica, and then it is replicating to the other consecutive clockwise one as per the replication strategy. Then the same coordinator, I think, reaches out and find out the next coordinator, and then I think it is giving it to the coordinator. So my understanding is the local coordinator and the remote coordinator are coordinating, and then maybe the remote coordinator takes control, and then it finds it out the first replica from there, and then it is going to the clockwise one.
So
Right.
by this it answers also, right, how it is selecting the node also clockwise way. So
Yes.
do you think still we need to configuring that one somewhere? No, right? Like according to this, if we know the first server, so first node,
Yeah.
we can go clockwise, other
Yes.
three, based on
Yeah.
the replication factor.
That's my understanding too. I think the first one is the one that it should use the partitioner and figure out the hash, but then the subsequent it should go clockwise to the right side. Yeah. Yeah. Any other question? I think uh, if everybody is good, I think we can go to the next one. Consistency levels. Yeah.
Yeah.
So any other, Srini, you wanted to take it from here, or? Yeah.
Yeah, I can read it, but I'll have to leave by 7. Yeah.
Okay.
So the Cassandra consistency level. So the Cassandra's consistency level is defined as the minimum number of Cassandra nodes that must fulfill a read or write operation before the operation can be considered as successful. The Cassandra allows us to specify different consistency level for read and write operations. Also, Cassandra has a tunable consistency. We can increase or decrease consistency level for each request. You can increase or decrease consistency level for each request. Oh, this is interesting, right? Consistency is not by table, by request. Okay. So there is always a trade-off between consistency and a performance. Higher consistency level means that more number of nodes needs to be respond to a read or write query, sorry, giving the user more assurance than the value present on each replica are the same. Okay. So the write consistency level for write operation, the consistency level specifies how many replica nodes must respond for the write to be reported as successful to the client. So the consistency level is specified per query by the client. The consistency level is specified per query by the client. So because Cassandra is eventual consistent, updates to other replica nodes may continue in the background. So here are the two different consistency level that Cassandra offers: 1, 2, 3, 1 or 2 or 3. So the data must be written to at least the specified number of replica nodes before a write considered successful. A quorum, the data must be written to at least a quorum or a majority of replica nodes. Quorum is defined as floor RF by 2 plus 1, where RF represents the replication factor. For example, in a cluster with a replication factor of 5, 3 nodes return success and the write is considered successful. All. Ensure that the data is written to all replica nodes. This consistency level provides highest consistency but lowest availability, as writes will fail if any replica is down. So the local quorum. Ensure that the data is written to a quorum of nodes in the same data center as the coordinator. Ensure that the data is written to a quorum of nodes in the same center as the coordinator. It does not wait for the response from the other data centers. What is the point here? So local quorum. Ensure that the data is written to a quorum of nodes in the same data set as the coordinator.
So in terms of replication, there could be indice replication and cross-dice replication, right? So what they are trying to say here is when it comes to indice replication, you have to maintain the indice quorum. And there could be replicas, there could be scenarios where you want to configure the replication across multiple data centers. So it doesn't have to wait for the responses from other data centers.
Okay.
Yeah.
Okay.
But can I say that if the replication strategy is a network topology, right, then only it is applicable. For simple, it will not be applicable, right?
What do you mean by simple?
I think so, yeah.
Right.
So we have
two strategies.
Yeah.
One is network and one is simple. Simple must be probably it will look for the
Only one data center.
Yeah. So since this quorum, local quorum, right, it says that it's applicable to that particular data center. So I think it by default it's a simple, right?
No, it is with the multiple data centers, but it does not wait for other data centers' response. It is dependent on the local data center response. That's what I understand. So
Yeah.
it has
So-
network, yeah, it is on network topology, but it looks at the local data center response.
Okay.
So yeah, even though it's a network topology, so each DC has their local quorum rules, right? So this is applicable to that local DC, but the same request will be going to the another DC's coordinator also, right? So but they will follow their quorum rules. So again, their local quorum comes into picture at that DC level.
Yeah, so if request, so data center 1 and data center 2, if request comes to data center 1, it makes sure that the response of the response receives the response receive the quorum response from its own nodes and doesn't wait. It will send the request to the second data center, but it will not wait for the response whether it is successful or not. So
Yeah,
once
makes sense.
that whatever that formula RF divided by 2 plus 1 is satisfied in its own data center, then it's done. It says
Yeah,
it consider it as a successful transaction.
Makes sense. Yeah.
makes sense. Yeah. So each quorum ensures that the data is written to a quorum of nodes in each data center. The data must be written to at least one node. The data must be written to at least one node. In extreme cases where all replica nodes for the given partition key are down, the write can still succeed after a hinted handoff has been written. Okay, I'm rereading it again. So the data must be written to at least one node. In the extreme case, when all replica nodes for a given partition key are down, the write can still succeed after a hinted handoff has been written. Okay, so any consistency level provides the lowest latency and the highest availability. However, it comes with the lowest consistency. If all replica nodes are down at write time, any write is not readable until the replica node for that partition have recovered and the latest data written on them. So here hinted handoff is just to my node, my replica nodes are down. So yeah, so hinted handoff is just to pass the so other node acts as a my replica, right? In this case.
I think coordinator node saves it locally itself, and whenever the replica comes back online, it just passes the hint to the
Hmm.
corresponding replica.
Okay, okay. So makes sense actually. The coordinator node has that information, or maybe it replicas.
Yeah,
One quick question here. It says like any means at least one node, right? This one node represents one coordinator node, or it is like one coordinator plus one replica.
one coordinator plus one replica. So
One replica.
coordinator is just acting as a coordination agent, right? But the
Okay.
data belongs to the node.
Okay.
So if the replicas are not present, right? So then only the hinted handoff comes, and as part of the hinted handoff, the coordinator node itself act as a replica for this request.
Yeah, but as Deva mentioned, Shrini, on top of that, you should have at least one replica online. If you don't have, if
No,
you have zero
again,
replicas online, then coordinator won't accept that, right? It will just reject it. But
no.
No.
That's not. They
So,
said
yeah.
last paragraph, right? If
Yeah.
all replica nodes are down at write time,
Yeah.
any write is not readable until the replica nodes for that partition have recovered. That means the coordinator has this information.
Yes.
It is not rejecting that write.
Yeah, that's my understanding too. So that one represents a coordinator, right? So which
Correct.
means coordinator is not really putting that into the replica. It's still keeping the hints in his own node, but there are no replicas up and says like it's written. But the read request comes in, it will wait, right? Till one replica comes up, and then it reads it from the hints off, and then the hint, and then it should finish the write. Then the read request can be respond back, right?
Yeah, I think this is the one of the best reason to say why Cassandra is very good for writes.
Mm. Yeah.
Sagar, are we on both same page?
yes,
Yeah.
yes, it's clear.
Okay. Any more questions?
I think they have explained hinted and down next to next
Okay.
paragraph.
Okay.
Okay. So the how does Cassandra perform a write operation? For a write, the coordinator node contacts all replicas as determine the replication factor and consider the write successful when a number of replicas equal to the consistency level acknowledge the write. Okay. So the next section is hinted after. Depending upon the consistency level, Cassandra can still serve write request when even nodes are down. For example, if we have the replication factor of 3 and client is writing with a quorum consistency level, This means that if one node is down, Cassandra can still write on the remaining two nodes to fulfill the consistency level, hence making the write successful. Okay.
Wouldn't it be successful until all it has written to all three of them?
No,
So
yeah.
RF by 2 plus 1, right? I think for the in this case, right? So 2 is the quorum consistency level, right? For us, replication factor is 2 for writes, right?
Okay.
This means that if one node is down, that's fine. I mean, it writes to the two nodes, I think.
Yeah.
What if it one more node is down? How it is acting? Maybe they might have explained in the down here. So here in this case, right, server 6 is a coordinator node and it replicas server 2, 3, and 4. In this case, the 4 is down. The 2 and 3 are still able to access it. Okay. So now when a node was down, comes online again, how should we write data to it? Cassandra accomplished this through hinted handoff. When a node is down or does not respond to a write request, the coordinator node writes a hint in a text file on the local disk. This hint contains the data itself along with information about which node the data belongs to. So when a coordinator node discovers from the gossiper that a node for which it holds hints has recovered, it forwards that write request for each hint to the target. Furthermore, each node every 10 minutes checks to see if the failing node for which it holds any hints has recovered. Okay, so here this paragraph is a lot of information, right? So one thing is like when a node is down and as part of the gossiping, right, the coordinator knows that the node is not available, right? Then it stores that write request metadata or whatever in a local text file, right, as an hint. So when that node is up, right, the coordinator is not going to read it from other two nodes. Instead of directly it has that same information, it will write directly into the recovery node, right?
Yeah. My understanding is also the coordinator every 10 minutes it checks because it has a hint of which node went down, right? So it has a hint.
Yeah.
So every 10 minutes it's checking whether that guy is up or not, right? What that node is.
Yeah.
Yeah.
So Sagar, for the gossiper, right? Gossiping, right? It is the health is a one use case.
Yeah,
Health of these nodes. Okay.
correct.
Maybe we'll come to know whether the data will be also gossiped or no.
So,
We'll
so
see.
this makes the older doubt clear as well, Shrini. So
Yeah.
looks like the gossiper only take cares of the heartbeat or the health. Whenever
Correct.
the coordinator knows that it is recovered, then either coordinator pushes it itself or the replica which was offline pulls it.
That we are not sure, right? Whether it's a push or pull.
So here, in the next line from the gossiper, it says that the node for which it holds hint has recovered. It forwards the write request for each hint to the target. Right?
Uh-huh. Okay. Then it's a
Yeah, it will never be a. I mean, like I am down. I'm a coordinator. I mean, I'm a replicant. I'm down, right?
Mhm.
I can't ask for my coordinator to send me the data that I have it, right? When my coordinator sees I'm available, and then it starts the writes to the coordinator. I mean, to the replica node, right?
Yeah, yeah. So you mean the direction will be from coordinator to replica always.
Yeah. Okay.
Yeah, because if you say the pull, right? Again, the write is a TCP call. I think so, right? In between these nodes, right?
Yeah,
Data, right? Because it's like one more extra step, right? I say like if I ask my coordinator, does my data is with you, right? Because how
oh yeah,
how how does the new replica node aware of the coordinator node, right? Again, it
correct,
has to send a gossiping. Where is my coordinator node, right? That will be complicated, right?
correct, correct.
Okay. So any more questions? So with consistency level, if all the replica nodes are down, the coordinator node will write the hints for all the nodes and report success to the client. However, the data will not reappear in any subsequent reads until one of the replica node comes back online and the coordinator node successfully forwards that write request to it. There, can you scroll up? So this is assuming that the coordinator node is up when the replica node comes back. So this also means that we can lose our data if the coordinator node dies and never comes back. So for this reason, we should avoid using any consistency level. Yeah, this is very interesting point. So what I was thinking here, right? All the hints will be written on the coordinator side. But I think that is not replicated to its replication, it replica nodes. All right. So if the primary coordinator node is down, that means the data is gone, right?
So if all the nodes go down, so 3 replicas are there, 3 replicas are down, but coordinator is active, it is having all the hints for all replicas. And due to some reason, if coordinator goes down, then that data is lost. That's what I understand.
Just to
That
confirm,
means
this will only cause when we are setting the consistency level to any, right? So
correct,
let's say
correct.
Only any,
if
yeah.
we don't set this any, then coordinator node, if all replicas are down, then there is a possibility that coordinator won't accept the write at all. If the
Correct.
consistency level is strong, only if the consistency level is set to any, then coordinator will try to save it locally.
No. Coordinator will accept the data, but it will not shake hand. Successful shake hand, it will not send. So if you read this also, where is it gone? Until one of the replica node comes back online and the coordinator node successfully forwards the write request to it.
So what is saying, right? My replication factor is 2. Let's take an example for write, right? So if I'm not setting as any, okay, consistency level any, right? So then if my out of 3 nodes, 2 nodes are down, only 1 node is there. That means, right, the coordinator node will not accept write. It will accept write, but it will it will throw an error, right? That write is not succeeded. That's what you're saying, Sagar, right?
Yeah. So the client should get a failed response.
Correct.
So write operation is failed. Something like that
Write
should be
operation.
written back.
That's my understanding too. Yeah.
I mean, Jayshree, did I interrupt you? Sorry for that. Yeah.
No, I didn't get the question. The replication factor is 2 or 3, and what is the case?
If a replication factor is 2, let's take an example. Okay. That means for write, that means
and
2.
Consistency, what is the consistency level?
It is not any. I mean, I don't know what's the other consistency level we have.
We can take this, right? 1, 2, or 3, and let's take the consistency level is 2, right?
Okay.
So the consistency level is 2. Let's take an example here. Okay, and that means like 2 nodes have to respond back for any write request. Okay.
Yeah.
So now 2 nodes are down. Only 1 node is there. 1 replica node is there.
Yeah.
Right. So coordinator receives a write here. What it does, it says that the replicas out of 3, 2 are down. So only 1 is there. My quorum is failed, right? It does not meet the replication factor, right?
Yeah. So it is failed transaction.
Yeah. That is what we have seen.
Okay.
Cool.
I think we were here.
Yeah. I'll quickly read this. So if a node is offline for some time, the hints can build up considerably on other nodes. So now when the fail node comes back online, other nodes tend to flood the node with the write request. This can cause issues on the node as it is already trying to come back after a failure. To address this problem, Cassandra limits the storage of hints to a configurable time window. It is also possible to disable hinted handoff entirely. So the Cassandra by default stores hint for 3 hours. After 3 hours, older hints will be removed, which means that if the node failed, which means if now the fail node recovers, it will have the stale data. Cassandra can fix the stale data by serving a read request. Okay, Cassandra can issue a read repair when it sees a stale data, which we'll go through this while discussing the read path. Okay, so one thing to remember, when the cluster cannot meet consistency level specified by the client, Cassandra fails the write request and does not store a hint. Okay, when a cluster cannot meet the consistency level specified by the client, okay, Cassandra fails the write request and does not store a hint. Okay, yeah, this is what we discussed for now.
Yeah.
Cool. Somebody can take over because I have to drop off. Yeah. It's a 7.
In fact, we can stop as well here.
Okay.
Is that fine with everyone?
Yeah, that would be
Yeah.
good actually.
Yeah.
Thank you.
So,
Are we going to continue tomorrow?
Yeah, let's at least try to finish the Cassandra chapter before we can switch back.
Okay.
This is
Okay.
important a bit, I would say, from my
Yeah.
point of view or perspective of it.
Okay.
Okay.
Yeah.
Thank you.
Thank you. Thanks everyone.
Thank you.
Thank you.
Bye.
Yeah.